Hello everybody, today we're going to be going over homework 1 video. So the problem that we chose was problem 2.16, and it states an adiabatic turbine expands steam from 500 degrees Celsius and 3.5 megapascals to 200 degrees Celsius and 0.3 megapascals. If the turbine generates 750 kilowatts, what is the flow rate of stream through the turbine? So the way we went at this was we established parameters in the beginning just based on what the question had to offer. So as you can see from our diagram here, we have labeled the in and out streams of the actual turbine. And then next we had to choose an equation. So since the problem states that it's adiabatic, we know there's no heat loss. We assume that the steam was at a steady flow rate and that there's no kinetic or potential energy just based upon where it was inside the system. So the equation that we ended up choosing is on page 72 of the book. And it's just the basic equation here, but this can be simplified with the fact that there's no kinetic or potential energy, so we can cross these out, and there's no expansion or contraction or heat loss since it's adiabatic. So when you simplify this equation, it's just going to be the H in minus H out times the flow rate plus the shaft work. So since shaft work is actually being done by the system, not to the system, it's going to end up being negative. So once we actually plug in the numbers, the equation at the bottom of your screen is what it's going to be looking like. So for the enthalpies, we actually just pulled them from Appendix E in the book. That's going to be found on page 858 and 860. So as you can see, we went ahead and rearranged the numbers a little bit. We took work and we put it to the other side, so it will become positive. With that, and then we did the simple calculations of subtracting both of the enthalpies, which is going to be equaling 585.7, and then we just divided that on the other side. At the bottom of the screen, you're going to see a little bit of dimensional analysis to make sure that our calculations are correct. So as you can see, once you cross everything out, it's going to equal kilograms per second, which is in terms of flow rate. So for the final answer you're going to be looking at once you actually calculate everything is going to be 1.28 kilograms per second.